All right, for question number 5 from section 2.7, we're graphing the following function y equals the quantity of x minus 4 to the second power. Now you should be familiar with the basic graph of the parabola, y equals x squared, where the vertex is at the origin and the parabola opens up. This minus 4 in the parentheses means that graph has been shifted to the right 4 units. So we're going to use our graphing tool, that is the parabola. We're going to first plot a point where the vertex is located, and this one has been shifted to the right 4 units. We're going to the point 4 and then plotting our first point, and we see that this pop-up window shows up. So this is a horizontal shift by 4 units, so we're going to type in 4 and see that it automatically shifts it for you. We can press save and check our answer. So that's our basic graph of y equals x plus 4. Now this next question is quite similar to it. Y equals the quantity x plus 3 to the second power. Now this plus 3 in the parentheses means that the graph has been shifted to the left by 3 units. So we go to our graph. Again, select the parabola graphing tool. Now we can place the vertex at -3, 0, but you see it automatically goes to the origin. So by using, again, the horizontal shift feature here, we're going to type in a -3 and see that the graph is transformed by moving to the left 3 units. Let's save and check our answer. Nice work. Let's go on to the next question. Okay, here we have our basic y equals absolute value of x graph, but with the +6 after it. That means our absolute value graph has been shifted up by 6 units. So we're going to use the absolute value graph tool, which is our V, and we're going to locate the origin, which would be our basic y equals absolute value of x, but this one has been shifted up 6 units. So we can plot one point at the vertex of 0, 6, and then we need to plot at least one other point. For example, when x is equal to 1, we see and we're to plug that into the equation here of absolute value of 1 plus 6, we would get 7. So we're going to locate 1, 7 and draw our second point, and the absolute value V graph is automatically displayed. We can save and check our answer to see that we have the absolute value graphed correctly. All right, here we have our function g of x equals 4 times the quantity x minus 3 squared minus 6. Now, several transformations have happened here. First, looking in the parentheses, the x minus 3 means our basic parabola graph has been shifted to the right 3 units. The minus 6 on the outside means that our basic parabola graph has been shifted down 6 units. So the vertex is going to be located to the right 3, down 6 of the origin. So 3, 6 is our vertex. Now the 4 in front of the quantity x minus 3 squared means that our whole graph has been stretched by a factor of 4. So we're going to get a really narrow graph of a parabola. Let's choose the parabola graphing tool, selecting the first point at the vertex, which is to the right 3 units, down 6 units, plot your vertex. You see that the basic graph automatically shows up, and we need to use this pop-up window to graph the vertical, horizontal, and the shifts and the stretches. So in terms of the horizontal shift, that's our -3 in the parentheses results in a +3 horizontal shift, a shift to the right 3 units. And the vertical shift, that's the -6, the vertex will be lowered by 6 units. So we're going to type in a -6. And now we need to apply the stretch. That factor of 4 means that we're going to have a very narrow looking parabola. We're going to save and check our answer. All right, so that shows you how to graph using those graphing tools in MyMathLab, as well as how to work about doing those vertical and horizontal shifts and stretches.